Okay, to solve this question, we need to know the rule that says if we have a polygon with n sides, the sum of the angles inside the polygon will be equal to 180 degrees times n minus 2. So our polygon here has 7 sides, so we'll plug 7 into our formula to get 900 degrees. So column A equals 900, in which case column B is greater, and our answer is B. Let's begin by finding the third angle in this triangle. We know that the sum of all three angles will be 180 degrees, so this remaining angle must be 30 degrees. Now notice that we have a 30, 60, 90 triangle. Well, we know a lot about this type of triangle. Shown here is a base 30, 60, 90 triangle with its corresponding sides. Notice that in the base triangle, the side opposite the 60-degree angle has length root 3. In our diagram, the corresponding side has length 4 root 3. So we can see that our diagram triangle is 4 times larger than our base triangle. This means that our shortest side in our diagram triangle will have length 4 times 1, and the length of our hypotenuse in our diagram will be 8. 4 times 2. Now notice that the angle at point B is 90 degrees. This means that our side AC must be the diameter of our circle. So we know that the diameter of our circle is 8. From this we know that our radius then will be 4, and now we can calculate the area of our circle. Using our formula, we'll replace r with 4 to find that we have an area of 16 pi, so our answer is C.
Alright, first of all, the circle originally has an area of x. So pi r squared equals x, where r is the original radius. Now the diameter is increased by 50%. And so if the diameter is increased by 50%, that means the radius is also increased by 50%. They're proportional to each other, so whatever percentage increase happens to one happens to the other. So radius has increased by 50%. What is the multiplier for a 50% increase? We change 50% to a decimal, 0.5. We add 1. 1 plus 0.5 is 1.5. 1.5 is the multiplier for a 50% increase. And so what this means is that R2 equals 1.5 of the original R. Okay, so the new area, of course, that's going to be pi times R2 squared. That's going to be pi times 1.5 R squared. And what is 1.5 squared? Well, 1.5 times 1.5, we can calculate this as 2.25. So we get 2.25 times pi times r squared. Well, the pi r squared, that's the original x. So this is 2.25 times x. Answer choice D.
All right, let's begin by adding some information to our diagram. Now we are told that the length of this arc is 4 pi, and our goal is to find the length of AC, which happens to be the radius of our sector. Now to solve this question, we'll use the following rule. It says that the arc length of any sector is equal to the sector angle over 360 times 2 pi r. So we know that the arc length is 4 pi, and the sector angle here is 30 degrees. We now have an equation we can solve for r. First, we can simplify the fraction to be 1/12, and now we can eliminate this fraction by multiplying both sides of the equation by 12 to get the following. Finally, when we divide both sides by 2 pi, we get r equals 24. So the length of AC is 24, and we'll add that up here. Okay, to find the volume of each tank, we'll need the formula for the volume of a cylinder. Now the question gives us the radius and height of each tank, so we'll plug these values in. And now remember that the question tells us that x equals 2y. So in each expression, we'll replace x with 2y. At this point, we can simplify both columns. And finally, we'll divide both columns by 2 pi y cubed to get the following. As you can see here, column A is greater than column B, so our answer must be A. Okay, we're told that angle CFD equals 85 degrees, so let's place this information on our diagram. And now we see that we have three angles on a line. We know that angles on a line add to 180 degrees, so we can determine that this angle must be 50 degrees. And now notice that we have two angles on a line here, 50 degrees and x degrees, and we know that they must add to be 180. So we can solve this for x to get x equals 130. So our answer is B. Okay, to begin, I should mention that it doesn't matter whether or not our two lines here are parallel. Here's why. Let's begin by finding the sum of A and B. Since angles A and B lie on the same line, we know that their sum must be 180. Let's find the sum of C and D. Well, angles C and D lie on the same line, so they must add to be 180. Over to column B. Angles E and F are both on the same line, so their sum must be 180. And angles G and H are also on the same line, so they must add to be 180. When we evaluate both columns, we get 360, in which case our answer must be C. Okay, there are several different ways to tackle this question. Here's one approach. We're told that the length of AE is 20 and EB is 17. So we now know that this pink length plus the yellow length of 17 must equal 20. So we can conclude that the pink length is 3. AB equals 3. We know that AD equals 14. We're given this. So 3 plus this gray length must equal 14. So the gray length, or BD, is equal to 11. And finally, we know that the length of CD is 6. So 6 plus this new yellow length must equal 11. So this yellow length is 5, and that's the length we're looking for. The answer here is D. All right, to begin, let's focus on this triangle right here. Since this triangle is a right triangle, we can apply the Pythagorean theorem to get the following formula. When we solve for x here, we see that x equals root 12. So we'll place this in column A. Now let's move over to this triangle. Once again, this is a right triangle, so we can apply the Pythagorean theorem to get this equation. And here we can solve this for y, and we see that we get y equals root 14. So column B equals root 14. As you can see, column B is greater than column A, which means our answer is B.
So this is an interesting one. The square has a side of 20, so the square's area has to be 400. Now we need the circle to have more area than the square, so it has to have an area bigger than 400. And of course the area of a circle, according to Archimedes' famous formula, is pi r squared. Well, let's start out just with C because that's a nice round number. If r is 10, r squared is 100, and of course pi is approximately 3.14, slightly bigger than 3. So this would be an area of 314. So that doesn't work. That's less than 400. Obviously, if we make the radius smaller, that's not going to work at all. Let's move up to 11. 11 squared is 121. Well, 121, let's do 121 times 3. That would be 363. So that's r squared times 3. What if it's slightly bigger than 3? Well, the next digit is 0.1. Well, 0.1 of 121 is about 12.1, and then we get into in the hundreds, so that would be single digits. So even if we add 163 plus 12.1 plus some single digits, we're not going to get up to 400. So that's not going to work. 12 squared is 144. Well, multiply 144 times 3, and that is going to be, well, even 140 times 3 is 420. 144 times 3 is going to be even larger than that. So we're well above 400 at this point, and obviously as we make the circle bigger, it's going to stay above 400. So E, F, G, and H are the answers.
We have a clock whose minute hand starts out pointing at the number 1. It goes in the counterclockwise direction until it points at 8. And we need to find out the measure of this angle in degrees. Well, we know that the angle around a full circle is 360 degrees. And there are 12 numbers on the face of a clock, and therefore the angle between any two consecutive numbers is 360 degrees divided with 12, which is 30 degrees. So we have a 30 degrees between 12 and 1, another 30 degrees between 11 and 12, another 30 degrees between 10 and 11, and so on. And therefore, the total angle between the numbers 1 and 8 is 1, 2, 3, 4, 5. That's 5 times 30, which is equal to 150 degrees.
Alright, to solve this question, we can ignore this information altogether. We only need to know one rule. That is, for all circles, the circumference to diameter ratio is always equal to pi. That's the definition of pi. So column A and column B are both equal to pi, in which case our answer must be C. Okay, to begin, let's add these angles inside our quadrilateral. Now I'm doing this for two reasons. First of all, we know that the angles inside any quadrilateral always add to 360 degrees, so we can write the following equation. Next, we know that this angle is 360, which means A plus E must equal 360. Similarly, since this angle is equal to 360, we know that B plus F equals 360. Applying the same logic, we can conclude that C plus G equals 360 and D plus H equals 360. At this point, if we take all of these sums and add them all together, the total sum will equal 4 times 360. From here, we're almost done. If we take the left-hand side here and rearrange the terms, we get the following. Notice that this sum happens to equal 360, so we can replace it with 360. From here, when we subtract 360 from both sides of our equation, we get A plus B plus C plus D equals 1080. So our answer, which will be up here, is equal to 1080. Okay, let's begin by adding the given information to our diagram. We are told that AF and BF both have length 3 root 2, so we can add that here. And we're told that AC has length 5, so we can add that. Now we're also told that AB is the diameter of the circle. Well, notice that this blue angle here is an inscribed angle holding the diameter. One of our circle properties tells us that this angle then must be 90 degrees. Similarly, this red angle here is also an inscribed angle holding the diameter. By the same circle property, this angle must also be 90 degrees. At this point, please recognize that we have a right triangle hiding in our diagram, and we know the lengths of 2 of its 3 sides. If we let the third side, the hypotenuse, have length x, then we can apply the Pythagorean theorem to get the following equation. When we simplify the left-hand side of this equation, we get x squared equals 36, which means x must equal 6. So we now know the length of side AB. From here, we should recognize that we have yet another right triangle hiding in our diagram. If we let the third side have length y, we can write the following equation. When we simplify this, we get y squared is equal to 11. At this point, we don't need to solve this equation for y any further. Here's the reason. Our ultimate goal is to find the area of the square BCDE. We know that one side of the square has length y, so the area of the square must be y squared. Well, we already determined that y squared is equal to 11, so the area of the square must be 11. So we'll add that up here.
A circle of radius 6 is cut into a number of sectors of equal area. Let's see what that means. We have a circle whose radius is 6 units. So r is equal to 6. And the circle is cut into sectors of equal area. So this is like a sector. This is another sector from here to here. And another one, and so on. They all have equal area, which means the central angles are all equal. And it's given that each sector has an arc length equal to 2 pi. So this length is 2 pi from here to here. So is this from here to here. So is this, and so on. They're all equal to 2 pi. And we need to find the measure of the central angle in degrees. Well, how many of these 2 pi lengths can fit into the entire circumference of the circle? Let's try and answer that question. The circumference of any circle is given as 2 pi times r. So this is going to be 2 pi times 6, which is equal to 12 pi. And each arc length being equal to 2 pi, we have 12 pi over 2 pi. You can cross out the pi's, and 12 over 2 is 6. So we have 6 such arc lengths around the circle. And if each central angle measures x degrees, we have 6 of them. So that's going to be 6x in all around the circle. And we know the angle around an entire circle is equal to 360 degrees. So we have 6x is equal to 360 degrees. Therefore, x is equal to 360 divided with 6, which is 60 degrees. And that's the measure of each of the central angles.
So here's how I would approach this. Let's just say that every box is 1 unit. And so the square altogether is 16. That's the area of the whole square. How much area is shaded? Well, let's break it into 2 pieces. This piece here is obviously 4. This piece here, well, it's half of that 3 by 3 squared. The 3 by 3 squared would have an area of 9. And so half of that would be 9 divided by 2, which we can write as a decimal as 4.5. And so we add 4 plus 4.5, the shaded region, the entire shaded region, is 8.5. Well, so our fraction would be 8.5 over 16. That's kind of ugly, having a decimal as part of the fraction. So what I'm going to do is I'm going to multiply the numerator and denominator by 2. You can always multiply by 2 over 2 because that's the same as multiplying by 1. 8.5 times 2 is 17. 16 times 2 is 32. And so 17 over 32, that is the proportion that is shaded. Okay, a couple things to say about this problem. First of all, notice that we have a right angle here at D. Up at point B, that's not necessarily a right angle. It might be, but we're not guaranteed of that. So we can't just do 17 squared plus 25 squared. Instead, we have to consider this right triangle on the left, on the right, and then move to the one on the left. So the one on the right first. We have a right triangle, hypotenuse 25, this side is 20, we need to know this. Well, we could square, but notice that we have a greatest common factor of 5. So what if we just divided everything by 5? If we divided everything by 5, then we'd get essentially x, 5, and 4 here. A blank 4, 5 triangle. Obviously, this is a 3, 4, 5 triangle, the Pythagorean triplet. And we just have to multiply back up times 5, so this has to be 15. So BD is 15. We'll now look at triangle ABD, where we have a hypotenuse of 17, and this length is 15, and the length that we're looking for, AD, we don't know. Well, here it's very useful to have your Pythagorean triplets memorized, because another Pythagorean triplet, one that often appears on the test, is 8, 15, 17. And because we have the 15 and the 17, we know that this side has to be 8. So AD equals 8.